Hey everyone, Maya here, and you're on Mathelingual. So, for today's last video, because I plan on doing a few short videos because it is just math. It's not like my talky tidbits where I really just ramble about stuff. So, I want to give a little preview for what I want to cover next week. Algebraic expressions. Yeah, I know, maybe some of you were real excited at that last statement, but I'm telling you, this is going to be fun. So, algebraic statements. Algebraic expressions. It's basically like the fundamental part of starting to learn advanced mathematics. Use it in geometry a lot, use it in calculus a lot. Point is, you need to know it. So I want to start, first I think we need to decipher with a little bit of word problems, because I think that's where everyone gets a little trouble at times with word problems, because nothing's explicitly said, okay? So I want to take a look at the difference between some very similar numbers, so expressions. So let's say I said I have 7 more than a number t, okay? How would I express that using mathematical lingo, using algebra? Well, I could write t plus 7. Right? 7 more than a number t. Okay? Yes, I know. By the commutative property, technically this is equal to 7 plus t, but for the sake of this example, I'm going strictly by this expression over here. 7 more than a number t. Okay, so t plus 7. It's pretty straightforward. Now, what about if I said I had the opposite, I'm just going to abbreviate here, the opposite of 7 times a number t, okay? What does that even mean? Okay, well, think about it. The opposite, so think positive and negatives, okay? 7 times a number t. 7 times a number t, that's multiplication. So we have 7t, but we have the opposite, so negative 7t, okay? I think that's pretty straightforward too. Now, this is the little fun part when we get into subtraction, because subtraction's kind of a little different. It requires a little bit more examination. So let's say you are told you have 7 fewer than a number t. Now, do not get confused on this part. 7 fewer, that does not mean 7 minus t. 7 minus t means you are subtracting t from 7. That's not the case here. We are subtracting t minus 7 because, right, 7 fewer than this number t. So when they say a number fewer than some letter, that letter goes first. 7 fewer than a number t. T minus 7, right? Because your final difference is going to be a number that is 7 less, 7 fewer than t, okay? So I'll write t minus 7, 7 fewer than a number t, okay? I think I made my point. All right, now on the flip side, what if you were told t less than 7? Okay, look at this, t less than 7. So that is going to be 7 minus t, because you look at it, you are subtracting t units, whatever, from 7. So you're going to start with 7, you're going to take out t. Like let's just start with a basic math problem. Let's say 5 minus 2. I mean, that's a little easier because we don't have to think about variables for a second. You would say that the answer to this, 3, is 2 less than 5. That doesn't mean when you say 2 less than 5, you don't write 2 minus 5. That's not 3, that's negative 3, which is totally a different problem. So think of this, just think of a very basic example when you think about this. Okay, so to recap, 7 more than a number t, t plus 7, or equivalently 7 plus t. The opposite of 7 times a number t, negative 7t, right? Because that's multiplication. 7 fewer than a number t is 7 minus t. You are taking 7 away from t. And t less than 7 is 7 minus t. Okay, we're good on that? I think so. So now we can start to get into a little bit of the related word problems. So let me just clear this mess off. Okay, so we're going to delve into a quick two quick little word problems. So let's say, now listen carefully because I'm not going to write down the whole thing, okay? Just make it clear. So let's imagine you start with, let's say you start with $20, okay? And you save $6 per week. So how can we represent the amount of money that you have at any given time, any given week, using algebra? Well, that's easy. So you start with $20. That is your starting point, okay? That is not going to change. But you save $6 per week, okay? So let's say after 1 week, you're going to have 1 week worth of $6 saved. So you're going to add that to your initial 20 to get 26. You have 2 weeks. You're going to have 2 weeks worth of $6 saved per week. That's $12, okay? So you're going to add 12 to 20, which is 32, okay? So if you're getting my flow here, how do we represent that with algebra? Well, we can just write 20 plus 6 times W, where W stands for the number, get this, the number of weeks. So 20, so we get 20 plus 6W. That is our algebraic expression to represent how much money. So if, let's say someone asked you at like 10 weeks, how much money did you save up after 10 weeks? Well, in that case, W would equal 10, so you would just plug that in. 20 plus 6 times 10 is 20 plus 60, and that is 80. See? No sweat, and you don't have to really work too hard into it. You just got to think, how many weeks? How many weeks? Really, how many weeks have passed? Okay? So, I want to go over a similar example. So this was like, you're gaining money, okay? But what if we thought about it on the opposite version? Let's say you start with $150. Let's say you start with $150, but you spend $2 every day. So you want to know, after so many days, how much money are you going to have left? So we can apply the same kind of approach that we did to this first example to this second example. So 150, that is your starting point, okay? But you are subtracting because you're getting less money over time, okay? You're spending $2 a day, all right? So we can do this as 150 minus 2 times D, where D represents the number of days, okay? D represents the number of days. So we have our algebraic expression, 150 minus 2D. So now let's say 5 days have passed, and let's say someone asked you, how much money did you have after 5 days? Well, in that case, D would equal 5, so you just, again, plug this in. 150 minus 2 times 5, that is 150 minus 10, and that is 140. So you could tell them, I have $140 left, and it's simple as that. You just think about, what is your initial point? What is your initial starting point? Or really in any algebra problem, what is an amount that is not going to change, that you're just given and it's not going to change? So that's your constant. And then, because it stays constant, that's why we call it a constant. And then you figure out, what is the amount that is changing? What is some kind of number that increases or goes down or goes up based on some kind of rate, okay? So in this case, it was the $2 a day. In the other example, it was $6 a week. So you just apply that kind of thinking to create these kind of algebraic problems. And that way, you can tackle even the strangest seeming of word problems involving forming algebraic expressions. So, hope that gave you a little bit of insight, and till next time, Mathelingual out.